Okay, this is going to be the third session that I give on this ACT prep for math. And these are the last few problems, about 28 problems, 29 problems that I'll work here. And there are some, I think the imagery is not so clear. So if I can see it or if I can make it out, we'll try to work it. But if we can't see it, then we'll just move on. And so, uh, again, we'll have this posted in YouTube in just a few days. And so, we look at this problem. It says for all pairs of real numbers m and v, where m is equal to 3v plus 6, solve for v. So just isolate v. So a couple of things we do. We subtract 6 on both sides. Then after that, we divide everything by 3. And so here, what that looks like is m minus 6 is equal to 3v, and then dividing by 3, we get m minus 6 all over 3 is equal to v, and so m minus 6 all over 3 is right there. Typically, you could go further, but the answer in its simplified form is not given. That would be m over 3 minus 2. So what's given is j. For some reason, my screen is kind of fuzzy. Well, my screen is actually dirty. Let's look at the next one. A parallelogram with dimensions in inches is shown, not too much water today for me, I would say, is shown in the diagram below. What is the area of the parallelogram in square inches? For a parallelogram, a square, the area is just the base times the height. So here our base would be 3 plus 6 is 9, and then times 4 for the height. So just 36 inches squared. So nothing there. So the students before, I'll share this with you as well, is that on the ACT, there for the math part, there's 60 problems. You only have 60 minutes, so on average, 1 minute per problem. Some of the problems, like these problems that we're seeing now, you can do those like in a matter of seconds. So you want to go through all 60 problems, the problems that you can do in a few seconds, work those. So you take all 60 problems, work through them. The ones you can do, work those quickly. The ones you can't do, or they may be more challenging, circle those, and then you come back to those at the end. And the ones that are more challenging, when you come back to the end, then you work through those, try to give yourself about a minute to work those problems. If it takes longer, then you put another asterisk or some kind of a notation by those that is even more challenging. So of the challenging problems, work through those that you can work. The ones that you can't, hopefully at the end, you may have 10, 15 minutes, and you may have, say for example, 10, 15 problems. Of those that are way challenging, that you have no clue, then definitely try your best to guess, an educated guess, to try to get those answers. But the ones that you can work, that are straightforward, you work those. So if a is equal to b plus 2, then what is b minus a to the 4th power? Well, simply this if statement, we're going to try to get the b minus a. So here, if we know that a is equal to b plus 2, then if I subtract a on both sides, and if I subtract 2 on both sides, then I get negative 2 is equal to b minus a, right? Okay? Do you see that? Exactly. So now, so here, this problem says, so find b minus a to the 4th. Well, b minus a to the 4th is the same thing as negative 2 to the 4th. Well, this negative 2 to the fourth is the same thing as negative 2 times negative 2 times negative 2 times negative 2, or negative 2 to the second, all raised to the second. So negative 2 to the second is 4 squared. That's just 16. Yes. You plugged in what again now? I'm sorry. Mm-hmm. Okay. That's it. Exactly. Yep, that's good. So here you said that you had A is equal to B plus 2. And so since you know that B minus A, and A is that B plus 2 to the fourth. And so here you get negative 2, the same thing, to the fourth. You get 16. Right. Very good. So for this one, a park has the shape and dimensions and blocks given below. A water fountain is located halfway between points B and point D. So if we draw a diagonal there and it's halfway, which of the following is the location of the water fountain from point A? Well, the neat thing is that we know that using geometry, if I draw a line here that's parallel to BC, so then I form a rectangle, and if this point here is the center of the diagonal, that means that the bisection here and the bisection here gives me midway between B and C, and then midway between C and D. So if that's the case, then notice that if this total side from A to B is 10, but from E to F is 7, that means here from C to D is 3. And if that's 3, then half of that would be 1.5. So here, now if I go up to B to C, notice that from A to F is 12 minus 3, so this side over here is 9. Well, half of 9 would be 4.5. So from A, let's see, from A to this point here would be the 10 minus 1.5, so that's going to be moving east 8.5. This is in blocks. And then I'm going to go up 4.5. So that's going to be D. Okay. Let's see, some of that looks like it didn't come out so well. I think it says the larger of two numbers exceeds twice the smaller number by 8. So let's see here. The larger of two numbers exceeds twice the smaller number by 8. And then the next sentence, the sum of twice the larger is 3 times the sum of twice the larger and 3 times the smaller number is 65. So if x is the smaller number, then what's the equation that we have? Well, let's take that first sentence. The larger of two numbers exceeds twice the smaller number by 8. So if x represents the smaller number, then here it says that the larger of two numbers exceeds twice the smaller number by 8. So then here 2x plus 8 is the larger number. So if 2x plus 8 is the larger number, and then if x represents the smaller number, then that second sentence, the sum of twice the larger, let's write that. So the sum of twice the larger, so twice the larger is 2 times parentheses 2x plus 8. And so it says the sum, so plus 3 times the smaller, 3x, is equal 65. That's the equation. So whichever one that is, because it seems like on that left side some of this information is trunked off, so we can't really tell. But it looks like it'll be that 1, 2, 3, that fourth one. Okay. Is that all right? Okay. Now that was fuzzy as well, but I think we can kind of make out what it is. It says something about a ladder of the fire department, or something, whatever. Fire department lean a 30-foot ladder on a building. The side of the building is perpendicular to the level, so that the base of the ladder is 10 feet away from the base of the building. So let's just draw it out. Let's say that's the side of the building. Let's say we have a ladder that's doing that. This is the base. It says that the ladder is leaning on the building that's perpendicular. The ladder, we know, is 30 feet. And then it said that the length on the base is 10 feet. So just using the Pythagorean, we get what we want. We call this side x. So it looks like x squared plus 10 squared is equal to 30 squared. So this is x squared plus 100 is equal to 900. X squared is equal to 800. Take the square root of both sides. X is equal to the square root of 800. Well, that's the same thing as 100 times 8. So we get the square root of 100 is 10. The square root of 8 is 2 times the square root of 2. So that gives us 20 times the square root of 2. And I think it said round that to some the nearest feet. So if you approximate that on your calculator, that's about 28 point something. Did you get that on your calculator? 28 point. Okay. It looks like it's close to 28 inches. Okay. Okay. Right. So that'll be the answer there. The next one, if we can make out this, the good thing is we have the diagram. So we have a square is circumscribed about a circle of 7 foot for the radius that's shown. What's the area of the square? Well, the good thing about the radius is that I can look at that radius this way and the radius there. So 2 times the radius would give me the diameter, which is the side of a square. So here the diameter is 14, and so the area is just 14 squared. And here that's 196 feet squared. Okay. The next problem, the ratio of the side lengths of a triangle is exactly, see, I cannot make out what that is. And see, yeah, I'm not sure. In a second triangle similar to the first, the longest side is 8 inches long to the nearest tenth of what, I couldn't make that out. So we'll move on. Well, we can work this out. In the figure below, ABCD is a trapezoid. E lies on AD, and the angle measures or is marked. What is the measure of BDC? This guy there. So what I did, I labeled some of these sides that I could not make out. So let's call this X, call that Y, call this one Z, and then I just called this one angle C, since the C is right there by itself. And a few things we know is that we have the so-called supplementary constant, that is that X plus Y plus 105 has to equal to 180. And then we know that 60 plus X plus Z, 60 plus X plus Z has to also equal to 180. And then we know that 30 plus Y plus that angle C, that's a triangle, has to equal to 180 as well. You're welcome. Now we can extract some things, that X plus Y is equal to 180 minus that 105, just get 75. Then also X plus Z is equal to 180 minus 60, 120. And I don't know if we'll need this, but we can write it Y plus C is equal to 180 minus 30, or 150 degrees. Okay. All righty. Yes. So the only thing, and you can do this anywhere you want, but you need to borrow something from geometry. And that is that if I take this AB and extend it, then I know that we get something about these complementary angles and supplementary angles, and we get knowing that if I have two lines that are parallel, and if I have a transversal that cuts two parallel lines, then I know something about those angles. I know something about the congruency of those angles. And what I have is 60 degrees is equivalent to, and I'm going to draw it out, this DB and then extend it upward. Right? Let's look at it. We extend this out. So AD is parallel to BC, just by the nature of how this the trapezoids are defined. So AD parallel to BC, which then means that this side here that I'm drawing in the blue, that angle is 60 degrees. So that becomes the key now. So if I know that that's 60 degrees, then I know that 60 plus 30 plus z has to equal to 180. So that means that z has to be 90 degrees. Well, if this is 90 degrees here, if this is 60 degrees, then I know that 60 plus 90 plus x has to equal to 180, right? And I think we have that here with this x plus z equal to 120. And here we get z is equal to 90 degrees. So that means that the x plus z is equal to 120. So that's x plus 90 is equal to 120. X is equal to 120 minus the 90, so x is 30 degrees. So if I know that x is 30, so x plus y, and y is what we're solving for, because y here is angle BDC, right? Y is equal to angle BDC. So if I know that x is 30, so we have x plus y is equal to 75. So x is 30 plus y is equal to 75. So y is equal to 45 degrees, and that's the angle BDC. And it looks like that's 45 degrees there. It's kind of fuzzy. So. Is everybody happy with that? Okay. Let's look at the next one. In a figure shown below, each pair of intersecting line segments meet at a right angle, and all the lengths given are in inches. What is the parameter in inches of the figure? Well, it was kind of questionable in terms of the lengths that they give. Like this 6 here, is that 6, you know? All right. So they're not giving us this guy. You see that? So what about this 4? So apparently this is 4, right? But they're not giving us that length here, right? And then over here, this looks like this is 6, but they're not telling us what this guy is. Right? And it looks to me that this length and this length are the same. Now, I could be wrong, but it looks like we can. So if that's the case, then this is 4. Right? Now, since they give us these sides here going up like 4 and 6, so that's 10 plus 4, that's 14. So this side over here is 14. Just the up and down. Now that inside stuff we don't know, right? So if that's the case, then if this is 4, then this has to be 10. Right? Do you see that? So if that's the case, then that leaves us to find out this length, this length, this length. Well, we got that in this length. But check this out. When you add them up, the red, they have to all equal to 26, right? So basically, that's 26 plus 26 plus 14 plus 14. That's the parameter. So the parameter is 2 times 26 plus 2 times 14. What does that give you? Is that the 80? Check that for me. I think that is 80. Okay. All right, let's look at the next one. Of the 804 graduating seniors in a central high school, approximately 2/5 are going to college, and approximately 1/4 of those going to college are going to a state university. So when you're looking for a percentage of something or an amount of something else, that's the multiplication rule. So I multiply 2/5 times 804, and that tells me how many people are going to college. Then of that number, if I multiply that result times 1/4, that tells me who are going to a state university. So the answer is simply 804. Work this out for me with your calculator. 804. This is times 2/5 times 1/4. What it looks like, that's 804 all over 2 times 5 is 10. So that's 80.4. So which of the following is closest? Estimate, right? That's going to be the 80. Okay. So if I want to know how much is in something else, if I'm given that total, I just multiply that percent or multiply that ratio, that fraction, times that whole, and it gives me the amount of the part, right? And then of that, if they ask you of that amount, then what's the percent or the fraction that's in there, you multiply that fraction times that result. So that's why we had 804 times 2/5, and then that result times the 1/4. If x and y are positive integers such that the greatest common factor, this type will be on that test. Because, matter of fact, I remember seeing this like 30 years ago when I took this ACT test. So if x and y are positive integers such that the greatest common factor of x squared y squared and x y to the third is 45, then which of the following should y equal? So to find the greatest common factor, of which, and this is just my blunder, but when I was in school, I never could get the greatest common factor, but I could always get the least common denominator, which they're the same thing. So for me, it's always the least common denominator, because fractions were always when I was in school, whichever part of the class that was the hardest, I spent most of my time on. And so in math class, 3rd, 4th, 5th, 6th, 7th grade, fractions like the hardest thing. So I spent a lot of time on fractions. So I got familiar with the least common denominator. So if you take x squared and y squared, x squared, y squared, and then if I compare that to, I'm going to write this out. This is x times y, and then we take that next number is x, y to the third. I'm going to write that out and separate that with the terms that it's associated with for the next number. So this is y times y times y. So for me, the least common denominator, but we're called the greatest common factor. So here, whichever is the what's common, because we're talking about the greatest common factor, we bring it down, times y times y. So this is x y squared. Now consider 45. 45 is 9 times 5. Well, that's 3 squared times 5. You match that up with the y squared times x. Looks like the y is 3 and the x is 5. So here it says, and then which of the following could y equal? The 3. You see that? Okay. If 115% of a number is 460, let's write that out. So 115% becomes 1.15 of a number. Of is always multiplied, so it's of times of a number. Let x equal the number. Is equal. That's 460. Can you, for me right now, solve for x? So x becomes, on your calculator, 460 divided by 1.15. What's that? Oh, how much is that? 400? I'm sorry, I can't hear you.
Yes.
400, okay. But then it says, what is 75% of that number? So 75% of 400 is 0.75 times 400. Okay. What do you get there? Yep. Okay. Is everybody fine with that? We remember that of is always multiplication, right? And then when you say a number, some variable, n or x, then is always equal. So of multiply is equal, then a number. I used x, but you can say n or whatever. So n or x. What is the distance in the standard xy coordinate plane between the points 1, 0 and 0, 5? You draw it out and look at it. So here, 1, 0, say is there. This is length of 1. And then 0, 5, that's on the y-axis. So this is the point 1, 0, and this is the point 0, 5. So you're looking for the distance, but this forms for us a right triangle. So the distance, let's call it d. And so this becomes 1 squared plus, I'm trying to work it out before I say it, 5 squared, I was going to write 25, is equal to d squared. So d squared is 1 plus 25 or 26. So d is equal to the square root of 26. Okay. All right. Any questions there? Okay, it looks like the ratio of the radii of two circles is 4 to 9. So the basic ratio, you got one radius is 4, and then the other radius is 9. It says, what is, it looks like, apparently, again, what is the ratio now of their circumferences? So the formula for the circumference of a circle is 2 pi r. So here, since we know that, So if I'm comparing the ratios here, if I look at the circumference of the first circle, that's going to be 2 pi times 4. Compare it to the other circumference, which is 2 pi times 9. You know, the ratios is just the same thing as fractions, right? So basically you have 2 pi times 4 all over 2 pi times 9. That still gives you the ratio 4 to 9, right? Because 2 pi is common in both circumferences. Okay. So let's see. Some of the wording is somewhat marked off. So something in the standard XY coordinate plane is tangent to the x-axis at 5, and then also tangent to the y-axis at 5. So some type of graph. And it could even say circle. So apparently it says, then which of the following is the equation of a circle? So if we draw it out, here for the x-axis, it says the circle is tangent to x equal to 5, and then the circle is also tangent to y equal to 5. So tangent means that it touches. So if it's a circle that touches at these points, and if it's tangent, that means that it touches, it doesn't cross. So this is a circle, and I drew an egg because my drawing is kind of not so good, right? But you get it. So this is 5 there, and this guy is 5. So if you recall, the formula for the circle is always x minus h to be squared plus y minus k to be squared is equal to the radius to be squared. Well, the radius is going to be 5. And then this translation from the origin for x is 5, so h is 5, and then the translation from the y-axis is 5. So here this is x minus 5 to be squared plus y minus 5 to be squared is equal to the radius squared, 25. Is that all right? Okay. I could not make out this part over here. Can you all make it out? I can't make it out. But it's just dealing with complex numbers rationalizing. So ideally you want to get rid of that I in the denominator. So you have to multiply by the conjugate of your denominator to the top and the bottom. If we could figure out that first part, that we could work it, but I can't tell what that is. Let's see here. Blue is good. Which of the following statement describes the total number of dots in the first n rows of the triangle? Something arrangement illustrated below. So here n represents in the first n rows of the triangle. So let's take the first row. So n represents here the number of rows. So if here n is equal to 1, so when n is equal to 1, I have just one dot there. So I just said comma. I don't know if I can I write a sub n is equal to 1? Just, and a sub n just represents the number of dots that I have. And then when n is equal to 2, the number of dots that I have here is 1, 2, 3, 4, because you have to include the previous row. Right? So here, a sub n is equal to 4. 1, 2, 3, 4. See, which of the following statements describes the total number of dots in the first n rows? Right? So if we say n equal 2, that means we're talking about the first row and the second row. So when n is 3, let's count up all the dots now. That's 4, 5, 6, 7, 8, 9. So a sub n is equal to 9. When n is equal to 4, then we count up 9, 10, 11, 12, 13, 14, 15, 16. You kind of see the pattern. So whenever I have n, the number of dots is n squared. You see that? So I'm assuming that if n is equal to 5, we should have 25 for a sub n. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yes, we do. So a sub n is equal to 25. So here, the first one says this total is always equal to 25 regardless of the number of rows. No, because the first total was 1, the second total was 4, so it's not always 25. The total is equal to twice the number of rows. No, because 2 times 3 here for that third row, 2 times 3 is 6, not 9. So that's not right. The total is equal to 5 times the number of rows. No, because if n is equal to 3, 5 times 3 is 15, not 9. This total is equal to the square of the number of the rows. You got it. You got it, brother. Okay. After polling a class of 20 music students by a show of hands, you find that 8 students play the guitar and 9 students play the piano. So given that information, what is the minimum number of students in this class, this music class, who play both the guitar and the piano? What's the minimum number? All right, that's a question for you. What is it? So you know that there's 20 people in all, and then the second fact you know is that there are 80 people, 80 students who can play the guitar. All right? 8, I'm sorry. And then you also know that there are 9 students that play the piano. Now, yes. Why do you say 8? Right. I mean, that you are exactly correct. The question is, what's the minimum number of students in this music class who play both? So if they're playing both, so you know that since of 8 and 9, 8 is the smallest number, right? So you got 8 people guaranteed that can play the guitar, and you don't know of those 9 students. It's possible that some of them can play also the guitar. There are 9 that play the piano, but you don't know that when they raise their hand, you don't know how many raised their hand twice, you know. But the minimum guaranteed is that that's possible. The minimum number of students that would play both definitely would be 8. And it's based on the smallest number that I'm given. If they told me that 5 students play the guitar and 9 students play the piano, then you would say that at 5 would be the minimum number, right, that play both. Very good. Which of the following is the set of all real numbers x such that x plus 3 is greater than x plus 5? Why don't you work that out real quick, and I'll give you 20 seconds. It's very easy. Okay, I'm going to count in my head. When I get to count, then you give me the answer. Oh, for real, yes. Okay. Tatum, what you got? You put B, the set containing all real numbers. Anybody else? Put B. What you put? Okay. So let's see. Let's see if that makes sense. So X on the left, that's the same X on the right, right? So if that's the same number, then if you subtract X on both sides, what do you get? You get X minus X plus 3 is greater than X minus X plus 5. You get 3 is greater than 5. Is that possible? It's the empty set. See that? Yeah. But then you got two X's, though. What do you do with those? You combine those values. Combine X because X is a like term with X. When you do that, it cancels out. So then even if you did that, you would have 0 is greater than 2. That's still impossible. No, that's fine. All right. That's right. Okay. This test, I'm telling y'all, and all these types of standardized tests, they want to find out, are you thinking? And sometimes it's the minimum thought that'll get you where you want to go. Don't exactly. You can overthink and you be just totally off and like, what are you doing? Okay. Okay. Good. All right. Uh, Pentagons have 5 diagonals, as illustrated below. How many diagonals does the octagon below have? Basically, you just want to connect all the diagonals and see how many you have when you connect them, right? So I get 1, 2, 3, 4, 5, and I'm sure there's probably some neat formula out there, but if you're like, man, you forget those formulas, So 1, 2, 3, 4, 5, and you come here, it's a different color. How many points do we have? Well, let's see if that works. Right. But you're gonna have some going to cross up. They're going to repeat exactly. So from here, so 1, 2, 3, 4, 5. You messed up my count. 6, 7, 8, 9, 10. 11, 12, 13, 14. 15, 16, 17. I'm missing some colors, so yeah, we got to go back. Repeat. So 17, right? So now from here, that's there, 17. So it's just 18, 19. Then I come here to this guy. Let's see. 20. See that? What'd you do? You got 20. What'd you do? Mm-hmm. Okay, good. That works too. Yeah, if I'm sure in geometry class there's probably some neat formula out there, and geometry for me has been so far removed because I don't even teach geometry in college. I just teach calculus and stuff higher than that. And so, but obviously you can just count them, just draw them out and count them and be done with it. So that took me no more than about, I don't know, maybe 12 seconds, right? Okay, 1, 2, 3, 4, 5. Okay, 20. You move to the next problem, right? But if you know that formula, by all means, use, yeah. Hey, okay. Hey, that's good. That's good. It works. Uh, Douglas wants to draw a circle graph showing the favorite colors of his friends. When he polled his friends, asking each their favorite color, so he has some circle graph. So he has 25. Uh, okay, let me start over. Use black. So he has 25. They like red, so I'm gonna draw that one in red. So 25. So, so let's say 25% red, 30% blue. So let me get the blue. Then 20% green. And then 10% purple. I don't know if I had purple in there. No, we don't. So we just said use the black for that. Well, obviously he wants everything to add up to 100%, right? So if you add up all those numbers, then what is that, 85? So we're short, what, 15%? And so here, and the remaining friends said colors other than red, blue, green, and purple. So the colors other than red, blue, green, and purple will be grouped together and an other. What will be the degree measure? 15. Okay. Looks like that sine theta is equal to negative 3/5. So sine theta is negative 3/5. There you are. Like mother, like son. Huh? So sine theta is negative 3/5, but theta is between pi and 3 pi over 2. So we're in that third quadrant, right? So here is pi over 2, 0, and then 3 pi over 2. So we're in this third quadrant. Then it says, what is tangent? Well, I use the Pythagorean theorem to just calculate just those sides. If I know that sine theta, if this is theta, if theta is here, 3, which is the opposite over the hypotenuse 5, then I need to find this leg here. So that's x squared plus 3 squared is equal to 5 squared. So x squared plus 9 is equal to 25. So x squared is 16. X is equal to 4. In the first quadrant, then that's just 3 over 4. But I'm not in the first quadrant. I'm in the third quadrant. Right? So if I look at this triangle, the tangent of theta is the opposite over the adjacent, 3 divided by 4. So tan theta is 3 over 4. We call that the reference. angle. Because now I have to find the tangent theta for that third quadrant. Right? Now, what happens to the tangent over here in this third quadrant is that I have to be mindful of the signs, because here this x-axis will give me here on this side negative values, and then over here the y-axis would give me also negative values. So in the third quadrant, x is negative, y is negative, right? Here, if I apply that to the triangle, this side represents x, the base, and then where that 3 is, that represents y. So basically what I have then is the tangent theta over here would be negative 3 divided by negative 4, which comes out to be 3 over 4. Here in so here x is negative, so it's negative 3, and then over here y is negative, negative 4, so we get 3 over 4. If we were in the so-called second quadrant, it would be x negative, y positive, so we would get negative 3 over 4. So I think that's the one, 3 over 4. It's kind of fuzzy with that print over there, but that looks like 3 over 4 and not negative 3 over 4. Is everybody okay with that? So we're looking at those trig signs. I must pay attention to whatever quadrant that I'm in, and the x values and the y values are with respect to the axis. So if I'm in the first quadrant, x is positive, y is positive. Second quadrant, x is negative, y is positive. Right? Third quadrant, x negative, y negative. Fourth quadrant, x positive, y negative. Which of the following systems of inequalities is represented by the shaded region of the graph below? Now, when I do systems of inequalities, I try to keep it simple. I try to picture myself skiing, and if I'm above something, then I'm staying afloat. So if y is a greater than, so I'm up top. You know, if I have a slope, some line equation, if it says y greater than, is everything up, and I'm skiing, right? If it says y less than, then I'm up under the slope and I'm falling. Okay. If it's the x-axis, and if it says x greater than, then I'm going to wherever x is positive. So that's going to be on the right, x positive. Positive values, positive infinity. If this is x less than, then it's going to be everything to the left. I'm going to x negative infinity. If it's a horizontal line, if it says y greater than, it's everything above that line, y less than, everything below it. If I have two lines, and then I have a shaded area, that's the intersection. The intersection of anything is always and, A-N-D, and. You got to make sure you know that, because here in the answers, you have ands and ors. Okay? In computer programming, the and represents for us multiplication. So we're trying to program a computer code in Pascal or in some type of basic language. Unix is one of the basic languages for the computer code. That we have what's called the AND gate. We have the OR gate, and so we have a sequence of zeros and ones. And so if there's an AND there, that's going to be some type of multiplication of a binary code, and the OR is some type of addition. And also represents intersection. Or represents union. So you got to be mindful of that. So now check this out. So you see this line here? This line looks like y equal to negative 2x. Well, how do I know? I'm just looking over here at the answers. Right? Look at the answers over there. So you get y greater than, y less than, negative 2x. So that line itself is negative 2x. But notice where that shaded region is, that's going to be y less than that because it's up under, right? It's up under negative 2x. So it's going to be y less than. Y less than or equal to negative 2x. So far, A could be an answer, B could be an answer. That's it, because that's both y less than. Here is y equal to negative 2x, but the shaded region is up under that, right? Now, I look at, this is x equal to 3, right? That's x equal to 3, x equal to 3. But now the shaded region is to the right of that, x greater than 3. So here, y less than equal to negative 2x, that's good. And over here, x is greater than or equal to 3. But now the question is it and or? And is the intersection. That means that where the regions or the graphs, they share a common graph. They overlap. So if it's or, it could be separate. Something over there or something over here. But if it's and, it has to be the common area. All right? The common area. So here, this shaded region is always going to be the and. So it's part A is the answer. Right? It's okay? All right, if f of x equal to x squared minus 2, then f of x plus h is equal to what? Now, you got to appreciate this because Isaac Newton and Leibniz and Barrow gave us this terminology. And the terminology was, if I'm at a stationary point, if I want to move from that point, then I want to take increments. And one noted historical math figure said we take increments of a. Another one said we take increments of h. So if I'm at x, I want to move over a little bit, x plus h. So, but where is that in terms of the function? So basically, wherever I have x, I replace the x with x plus h, and then I simplify. So look. So if we know that f of x is equal to x squared minus 2, those three gentlemen that I just made mention of, they were trying to calculate if you had something and you want to calculate its, this is good. If I have this object and they throw it and they say from every second and even splits of seconds, can I calculate its distance? And when I calculate the distance, can I calculate its velocity? So as that pin that I threw, notice that it went up, it crested up, and then it fell down, right? So I can calculate the velocity of those incremental changes. And they called that velocity the derivative. Right? And this is what they were using. So as x, the object moves h units over, what's its speed? And then I calculate some type of ratio of those speeds, some kind of formula that gives me the speed, and we get some type of function that we call the derivative. So now f of x plus h simply means wherever you see x, you write in parentheses x plus h. So this becomes x plus h to be squared minus 2. I use your algebra to simplify that. So here, this is x plus h times x plus h minus 2. You simplify that. That's just FOIL that out. First time the first is x squared. Outer times the outer is plus xh. Inner times the inner is plus hx or xh, same thing. Then the last time the last is plus h squared minus 2. The two common terms are those terms in the middle. You can combine those. So this is x squared plus 2xh minus 2. I left off the plus h squared, I'm sorry. That's what happens when you eat chicken and no vegetables for lunch. So plus h squared minus 2. All chicken and no green beans. You leave off of h squared. So, you look back up and see which answer that is. Looks like this guy right here. Is that all right? Okay. Is that okay? All right. So here, which of the following is the graph in the standard xy coordinate plane of y equal to 2x squared plus x divided by x? But notice that the numerator has a common term of x. It's x squared, which is x times x, and then plus x. So you can factor out that x, if you will, or you can just write this as 2x squared divided by x plus x divided by x, which is just 2x plus 1. So we simplified this rational expression into a linear form, 2x plus 1, which is just a line with y-intercept 1, and the slope is I go up 2, I go over 1, I go up 2, I go over 1, I go up 2, I go over 1, right? That's the 2 in front of the x. So it's a straight line. So it's either A, B, or C. All right? So now it's a straight line with y-intercept 1. That means it crosses the y-axis at 1. So that's either A or C. It rules out B, right? Because B is going through the origin. Right? So I don't want B. So it's either now A or C. But now the question is, well, you can get it. The y-intercept is 1. That means that when x is 0, y is equal to 1. So it has to be that. See that? Look here. If x is 0, y is not equal to 2. Look at the formula over there. If x is 0, that means that's 2 times 0 plus 1. Well, 2 times 0 is 0 plus 1. That's just 1. That's not right. So it's A. And you see that circle? Let me draw that out. See this graph here. X is 0, y is 1, x is 1. I get 2 plus 1 is 3. So x is 0, y is 1. Here, I forgot to put those little slash marks there. I'm sorry. So x is 0, y is 1. Here, x is 1, y is 3. Then I connect those two guys. But I got trouble. at one point. Because one of these points, this graph is said to be discontinuous. It's not continuous. What point is that? 0 and 1. Because remember, originally it's 2x squared plus x divided by x. So if that's the case, that x in your denominator cannot equal to 0. If so, you'll be dividing by 0. And can you divide by 0? No, it's not allowed. So we remove that discontinuity. So that point would have been the 0, 1. So that's why they have it circled over here at part A. So at that point, 0, 1 is circled because it does not include that. So discontinuity. See if I can. Took too much off. Dag blasted. Okay. A triangle ABC is reflected across the x-axis to have the image triangle A prime, B prime, C prime in the standard XY coordinate plane. Thus, A reflects to A prime. The coordinates of A are C and D. So the coordinates of A are C and D. This is point A. So it says here that it's reflexive, or that means that it has this mirror image across the x-axis. So that means it is doing this. Right? So if point A is C comma D, then here, this point A prime has to be what? In terms of the positive or the negative signs for C and D. Okay, which one? Which one's going to be negative? Check this out. Check this out. Here's the x-axis. The x-axis, it splits quadrant 1 and 4, right? But x is always positive. See that? X-axis doesn't change. The y values change from positive to negative. So little c is going to be positive because that represents x, right? It's the same x. But y is shifting from positive to negative. So here, this is... Shouldn't point what now? If it's reflected, it's supposed to be a mirror image across the axis, the x-axis. So if I fold the paper on the x-axis, I get its mirror image downstairs.
Okay, so the B would be all the way.
Oh yeah, it's supposed to be a B and a C. Letters are dummies, are not human, so you can change a letter and it won't get upset. It won't start fussing. People will. Yeah, it's supposed to be. Yeah, just. Yeah, it's a B there. C. Yep. I wasn't concerned about those guys. I was only concerned about A anyway. Yep. Good deal. Thank you. Okay. If x equal to 2t minus 9 and y equal to 5 minus t, which of the following expresses y in terms of x? Simply put, get rid of t. You know, so if you ever had somebody in your life that you want to get rid of, here's a mathematical way of doing it. It works. It works. And people do that psychologically. You know, there are people who will ignore you when you're in the room, and they will act like you're not there. They have eliminated you as being T. We're going to eliminate T. It's a mathematical concept, right? Yeah, and it happens, you know. It happens. My wife, she eliminate me. I can be talking sometimes, and she's doing something else, and I say, "Did you hear me?" She said, "Yeah." I'm like, she didn't hear me, you know. And then I gotta admit, I'd probably do the same thing too. Okay, so doesn't matter which equation you use first. You can take this x and solve for the t, or you can take this y equal to 5 minus t and solve for the t. always try to take the one that's, to me, I think is the easiest to get. So first you want to get t by itself. So in one equation, solve for t. Okay. Substitute that expression for t into the other equation. So, I'm going to take here y is equal to 5 minus t. I'm going to solve for t. I'm going to add t on both sides, subtract y on both sides. So that'll give me t is equal to 5 minus y. Do you see that? Add t on both sides, subtract y on both sides. So t is equal to 5 minus y. I take this variable expression, this expression here, and I plug that into the second equation where I see t. Here, that's x is equal to 2 times t. This is parentheses 5 minus y minus 9. So I get x is equal to 10 minus 2y minus 9. So it looks like they're getting y by itself, so I'm going to solve for y. So here, let's get the 10 minus 9. You can simplify that. X is equal to 10 minus 9. That's 1 minus 2y. Right? Add 2y to both sides. And then subtract the x on both sides. Can I do that at the same time? Is that okay? I'm going to add 2y to both sides, subtract x on both sides. So I get 2y is equal to 1 minus x. Now divide both sides by the 2. And you get y is equal to 1 minus x all over 2. Now see how they wrote the answer. There it is. Y is equal to 1 minus x over 2. And if you have a question about something, please ask. You can ask now. Ask anytime. Right? Is that okay? Is that okay? Okay. You sure? Putting your hands like that, that means something. Okay. Long day, I tell you. You all been in school all day, so long day in school, and you leave school and you go right back to school, right? Oh boy. Sorry, Charlie. Sorry, Charlie. It's an old commercial. You don't know, but okay. What is sine of power over 12, given that power over 12 is equal to power over 3 minus power over 4? In that sine of alpha minus b is equal to sine alpha cosine beta minus cosine alpha times sine beta. Right? You may use the following table of values, but we appreciate that. So I'm going to use this formula to write out what I need to write out. So here's what I have. I have sine of power over 12. That's what you're looking for. Well, they tell you that power over 12 is the same thing as power over 3 minus power over 4. I got to erase that out. I can't see what I'm trying to get. Okay. Maybe use this color. And do what my mother said and take your time. No, as a deacon at the church, he's always saying, take your time, take your time. Trying to get the right message right when you're preaching it. And old Deacon Scruggs and say, take your time, take your time. So I got to take my time. So, yes, this is sine of, yes, pi over 12 is the same thing as sine. Based on this is the same thing as sine of pi over 3 minus pi over 4. With that, taking alpha to be pi over 3 and beta to be pi over 4, right? Just based on here, this is sine of alpha minus beta. So this is equal to, going by this, sine of alpha, that's pi over 3, times cosine of beta, pi over 4, minus cosine of alpha, pi over 3, times sine of beta, that's pi over 4. Now using the chart, we get what we need. So here this sine of pi over 3, sine pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Minus cosine of pi over 3. Cosine of pi over 3 is 1/2. Times sine of pi over 4, square root of 2 over 2. Simplify that. This is the square root of 6, right? All over 4 minus the square root of 2 all over 4. And can't you simplify that? They're both divided by 4, so they have a common denominator. So this is the square root of 6 minus the square root of 2 all over 4. Looks like this answer right here. Okay? All right. Well, I think that's going to end it for me. Any questions? Any questions? Okay. Well, we're going to stop there.